In 6.1, make sure that you read the text. There are many definitions and many descriptions of different just basic geometry terms that you'll want to be familiar with. Points, lines, planes, angles, angle measurements. So make sure that you read all of that in your textbook. Number 1 here says, true or false, a line extends infinitely in both directions. And that is true. If you were to draw a line, those arrows at the end indicate that it's going to keep on going infinitely in both directions. Notice that on number 1 there it says a point has a slightly positive length, width, and thickness. That's actually false. There you'll see in the definition that a point has absolutely no length, width, or thickness. It's just a representation. Okay, let's look at number 2, which deals with angle measures on a clock. It says a hand of a clock moves from 12 to 5 o'clock. Through how many degrees does it move? What you'll learn in your text and know that is that a circle has 360 degrees. And so if a hand is moving from 12, so 1, 2, 3, 4, 5, so it's going to move all the way around to the 5 o'clock position. Okay, notice that is obtuse. Then if each one of these is 1/12 of the whole, if it's moving all the way to 5, it's moved 5/12. So 5/12 of 360 degrees, we would go actually ahead and cancel out a common factor of 12, which would leave me with 30, and then 5 times 30 is 150 degrees. Okay, 2b, find the measure of each angle marked with the question mark. Zoom in a little bit. So what we have indicated here is anytime you have a square on the vertex of that angle, it does indicate that that's a right angle. So what we have here are 2 complementary angles, since they would add up to be 90 degrees. So 25 degrees plus, we don't know what, the question mark, so I'm going to let that be x, will give me a total of 90 degrees. Subtract 25 from both sides, and that leaves x as being 65 degrees. So you could set up an equation like that, or you could just simply know that, well, if the whole angle is 90, and I take away 25 as part of it, what would be left is 65 degrees. Okay, 2c, the measure of an angle is 3 times greater than its supplement. Use an algebraic equation to find the measure of the angles. So what we're going to do is find a variable. So this says the measure is 3 times greater than its supplement. Okay, when you see a comparison word like that, then its supplement, whatever comes next, that's what we're going to begin letting our variable represent. So we're going to let x represent the supplemental angle. Okay, and then we know that the measure of the angle is 3 times, it says greater than x. So if it's 3 times greater, it's actually, and there's a problem like that, sometimes you see the greater than, it's a little bit confusing, but it's 3 times as large as x. That's going to be represented with 3 times x. That's the measure of our angle. Okay, so then we see that it's a supplemental angle, which means that these 2 angles would add up to be 180 degrees. So the 3x plus its supplement would add to be 180. That means 4 times x is 180. Divide both sides by 4. X is equal to 45 degrees. Now that's one angle. That's actually the one that we've allowed to be the supplement. So then 3 times 45 is 135. So your 2 angles would be 45 degrees and 135 degrees. Those would add to give you 180. Okay, 2D deals with vertical angles. If this angle is 72, its vertical angle, which is angle 2, is also 72 degrees. And then the remaining angles, if I look at the 72 degree angle and angle 1, notice that they form a straight line, which is 180 degrees. So 180 minus 72 is equal to 108. So if this angle is 108 degrees, then this angle is also 108 degrees.